The following is a production of New Mexico State University.
This is an important moment. You're about to start on the design and construction of a home sewage treatment system. The common home sewage treatment system is a septic tank and a drain field. Before you proceed, let's look at how this system works. The better you understand the system, the better you can build your own system to protect your family's health. The water in this system is not pure, but may contain many infectious diseases such as hepatitis, dysentery, and cholera. These diseases can make your family extremely ill or even cause death. At particular risk are the young and the elderly. There are two main parts to your home wastewater treatment system. The first part is the septic tank that removes solid material. The second part is the drain field that disposes of the wastewater. The septic tank is usually divided into two sections or compartments. The first compartment removes grease and solids that will plug up the drain field and cause it to fail quickly. It is critical that the tank not become overfilled with these waste solids. This is why the septic tank serving a home should be pumped every 2 to 5 years. The first compartment is so important that there is a backup compartment to ensure that the septic tank doesn't fail in doing its job. If the tank should fail to retain the grease and solids, the drain field will become plugged, and the partially treated sewage will surface where family members may be exposed to the disease-carrying bacteria. The wastewater leaves the septic tank and is distributed over the drain field area. The drain field is where the rest of the sewage treatment takes place. The bacteria in the soil under the drain field treat the sewage and destroy the disease-carrying bacteria before they reach the groundwater. The soil that treats the sewage must be protected from oil, grease, and solids. This is the main job of the septic tank. To ensure long life of your septic system, the drain field must be designed using the correct soil type or soil absorption rate, large enough to treat wastewater, not just get rid of it, and separated from the groundwater and fractured bedrock by the appropriate distance. Now that you know all about your system, let's consider some of your options and the cost associated with these options. The cost information presented here is only a brief summary for comparative purposes. Details can be found in the cost section of the accompanying notebook. The costs refer to a septic system designed for a 3-bedroom home and constructed of new materials. For an accurate cost comparison of alternatives, you will need to work through the real costs for your situation. In 2001, the cost of having a conventional septic tank and chamber drain field installed by a certified installer in New Mexico ranged in price from $1,700 to $2,600, and the installer usually filed the permit application. The cost of installing a septic tank and chamber drain field using 100% hand labor is about $1,050, and you can expect to spend at least 32 hours digging for a typical system. In addition, you will be responsible for the system design and filing the permit paperwork. The paperwork is daunting, but if you request assistance, the regulators will do what they can to help ease the paperwork burden. If you have counted the cost and you are sure that you would like to install your own septic system, the next step is to consider the design and layout of the septic tank and drain field. Begin your design with a site drawing showing the following points of interest: property lines, building locations such as your house and garage, driveway and sidewalk locations, water well on the house site and wells on the neighboring property, surface waters and arroyos, elevation lines, and electric, gas, cable, and other utilities. Your lot plat is ideal for this purpose because it has been surveyed by a registered land survey and is drawn to scale. Using this drawing, the approximate area of an average septic tank system can be used to check whether your lot is large enough to comply with minimum setback requirements. Assume your system will service a 3-bedroom house on moderately permeable soils. Assume the tank will be about 12 foot by 8 foot and the drain field will be 2 sections 10 feet apart, 100 feet long. Sketch this system on your plat and draw in the setbacks. This drawing is of adequate detail and quality to satisfy most regulatory agencies. The drawing used for your permit application must match your final design. Check your approximate drawing, and if you cannot meet the general setbacks, there is no point in proceeding with the rest of the design. It is time to rethink the project. If the system appears to meet the setback requirements, it is time to do a detailed design. The step-by-step design of the system varies with regulatory jurisdiction and is covered in literature provided by your local environmental agency. This literature is also included in the notebook which accompanies this video. In determining your final design, be sure footing and roof drains are not connected to the septic system. Also, water softener recharge water should not be discharged to the septic tank. It is bad for both the bacteria treating the wastewater and the soils in the drain field. Using your final design, fill out your septic tank permit application. You must complete and submit your permit application prior to beginning construction. To complete this application, you may need other permits, including a building permit, water rights permit, MHIP or mobile home installation permit, and utility hookup permit. Before you start construction, make sure you have all the required permits. To begin construction, check that the following tools and supplies are available. Typical tools include safety glasses, garden rake, a shovel, a 24-48-inch carpenter's level, an 8-foot 2x4, heavy rubber gloves, a ladder, a PVC saw, a hammer, pliers and screwdrivers, and measuring tape. You may also need the following supplies: PVC glue, PVC cleaner, bituminous sealer such as mastic, stakes, mason string. The common types of septic tanks are reinforced concrete, plastic, and fiberglass. For the remainder of this video, the fiberglass and plastic tanks will be referred to as plastic. For both types, the first step in septic tank installation is to take the location drawing from your permit application and stake the location of the septic tank on the ground. When you dig, the hole should be approximately 2 feet larger on each side than the septic tank being placed into the hole. This measurement is from the bottom of the hole, not the top, since the sides of the hole are seldom straight up and down. The depth of the hole for the septic tank is usually determined by the drop in the pipe required for the water to flow from the house to the septic tank. Calculation details are given in the notebook section entitled Pipe Drop Calculations. A typical depth to the top of the tank inlet when the tank is 15 feet from the house is around 28 inches. A word of caution: digging a large hole may be dangerous if the soil is unstable or too sandy. The sides of the hole may need to be supported. The available methods for setting the pipe slope from the house to the septic tank will use one of the following: carpenter's level with 1/4 inch per foot grade mark, string level, water hose, torpedo level with laser pointer, batten boards, 2x4s. The most common technique is the carpenter's level with 1/4 inch per foot grade mark. Insert a section of 2x4 into the end of the 4-inch pipe coming from the house. Place the carpenter's level along top of the 2x4 and adjust the slope so the bubble just touches the line closest to the pipe. Use of a string level is another simple technique for setting pipe slope. Hang the string level from the string and adjust the string until the bubble is in the middle of the level's bubble glass. Unfortunately, it is difficult to keep the string tight and level, and you must measure over from the string to the center of the trench and then down to the floor. The water hose technique is widely used. The hose forms a long U shape in the trench. When it is filled with water, the 2 water surfaces at either end of the hose will be at the same elevation. Measure down from this water surface elevation to get the proper trench depth. A manufacturer makes a kit of this type with screw-in ends, clear tubes, and marks on the tubes. This technique is easy, but it is a bit messy and time-consuming. The last leveling technique we will mention is a new easy technique: laser leveling. You can purchase a laser torpedo level for around $150. or build one for $10 to $15. The laser level is attractive because of its ease of operation. To build one, attach a standard laser pointer to an inexpensive torpedo level. Mount the torpedo level on a wooden stake at the head of the trench. Use the torpedo level to make sure the laser pointer is level. Place a pole with one end on the bottom of the trench and mark where the laser strikes the pole. As you dig the trench, use the pole to check the bottom elevation approximately every 5 feet. Now that the trench is dug, install the drain pipe. 4-inch minimum diameter sewer pipe with watertight connections should be used between the house and the septic tank. The possible exception to this is mobile homes in place where local code allows 3-inch diameter sewer pipe. The sewer pipe can go all the way to the septic tank. There are very few septic tanks with a 3-inch inlet, so it will be necessary to use an adapter to adjust the 3-inch pipe up to a 4-inch pipe. Carefully level the bottom of the hole before the septic tank is in place. This will make tank installation easier. Level the septic tank hole using a 2x4 and carpenter's level. Again, do not place a 5-ton reinforced concrete tank yourself. This should be left to the tank provider. You may dig the hole to reduce cost. After the septic tank is in place, inspect the tank for damage. For the protection of your drinking water, it is important that the tank be watertight. Many regulations require the homeowner to fill the tank with water and measure the loss of water over time. This is an excellent idea even if it is not required. A watertight tank should not lose more than 1 inch of water in 24 hours. A new tank will absorb some water. It is best to fill the tank and 24 hours later, top off the tank and begin the actual test. Leave the water in the tank, since the tank needs to be full when it is placed into operation. The clean water in the tank improves the tank operation for the first few days. There are baffles at the inlet and outlet to your septic tank to prevent the water from taking a shortcut through the tank. The baffles shown here are concrete baffles. However, many tanks may have a 4-inch diameter PVC T for a baffle rather than cast-in-place baffles. This facilitates putting an outlet filter or biofilter in the septic tank. If you can afford one, a biofilter is highly recommended for the protection of the drain field. When installing the inlet and outlet pipes, be careful to insert the pipe only 1 to 3 inches. If the pipe is inserted further, it may run into the baffle and plug the end of the pipe. This can greatly reduce the flow capacity of the tank and cause clogging and sewer backups. This error is usually noticed when or if the tank is inspected, but the problem is not always easy to correct at that time. The tank's inlet and outlet connections and seams must be sealed to protect against groundwater seepage and tree root intrusions. Your septic tank may have either a large diameter hole or a neoprene collar as an inlet to the tank. If the tank has a neoprene collar, the collar will seal the inlet and outlet holes. Wet the collar to allow the pipe to slide in. Do this with water, dish soap, WD-40, or hairspray. You may wish to improve the seal on some collars by clamping the collar to the pipe using a large hose clamp. If the tank has a large diameter hole for the inlet and outlet pipes, these holes must be sealed after the pipe is inserted. Use grout, mortar, or a bituminous sealant such as mastic. When using mastic, it is important to check the pipe for adequate support. Gently press down on the pipe with your shoe. If the pipe moves, it needs better support. Without support, the pipe will settle during backfill and create a void at the top of the pipe. This may cause problems later if the tank must be hydraulically tested before it is put into service. One of the most common failure points in hydraulic testing is the top of the pipes. After the seams have been sealed, your tank is ready to be inspected and, if required, hydraulically tested. Now it is time to install the outlet pipe from the septic tank to the drain field. Use a 4-inch minimum diameter sewer pipe with watertight connections between the septic tank and the drain field. Some regulations allow the use of less expensive pipes here, but tank settling may snap the lower quality products. Once the inlet and outlet pipe and tank cover are installed, the septic tank can be backfilled. But before you backfill, allow for easy long-term access to your tank for future inspection and maintenance. The septic tank location is often a critical piece of information that is lost with time. Proper installation and marking of access ports can save a lot of headaches in the years to come. It is also wise to tape a septic tank location map to the inside of the master bedroom closet. Backfill the soil over the tank to a height of 6 inches to allow for settling and to divert surface runoff. If your tank is plastic instead of reinforced concrete, the excavation and leveling steps are the same as for those for the concrete tank. The difference is in placing and backfilling the tank. When using a plastic tank, many manufacturers suggest that a 6-inch bed of clean sand be placed in the bottom of the hole and leveled prior to placing the tank in the hole. The backfilling operation is extremely important with plastic tanks. Begin by filling the tank with water to 1/4 the sidewall depth. Place the top on the tank when backfilling a plastic tank. Without the top in place, the hole can become deformed during backfilling, so that the cover cannot be installed after the backfilling is complete. You can both remove and replace the top every time you add water, or you can add the water through the inlet pipe. But the top must be in place as the soil fills the gap around the tank. The water in the tank will keep the soil from crushing the tank walls as the backfilling is performed. Do not overfill the tank or it will bulge. The water and soil provide balancing forces during the backfilling. Backfill the tank up to the water elevation using pure native soil without rocks. Fill another 1/4. Total depth is now 1/2 of the tank depth. Repeat the backfilling operation. Continue this activity until the tank is buried. Again, backfill the soil 6 inches over the top of the tank. Whether your septic tank is plastic or concrete, fill it with clean water before you put it into use. The full tank allows the baffle between the first and second compartment to keep the soils in the first compartment and away from the drain field. If any septic tank is left idle for a period after it is installed, it should be filled with water. If there is no water in the tank and the groundwater rises, the septic tank may float out of the ground. Although it may not come clear out of the ground, it may shift enough to break pipes and disrupt the drain field. The two most common types of drain fields are the gravel and pipe drain field and the chamber drain field. Both drain fields require digging a trench, which will contain the distribution system. In clay soil, the trenches for the drain field should be only dug when the soil is dry and crumbly. Smearing and compaction due to construction in wet soil decrease the ability to absorb wastewater. Before digging the entire trench, dig down to the required depth and examine the soil. Take a handful of soil from what will be the trench bottom. If it forms a 1/8 inch diameter ribbon when rolled between the palms of your hands, the soil is too wet to work with. If the soil crumbles, digging may proceed. If the soil is sandy and will not form a ribbon, as described above, don't worry about the soil moisture. Dig your trenches to the required depth and width. Check the bottom elevation as discussed previously to ensure that the trench bottoms are level within local code specification. If the soil on the bottom is mostly clay, use an excavating bucket with teeth to rake each trench bottom to final bottom elevation. Rake to a depth of 1 inch to open up the soil for water seepage. This can be performed by using a garden rake. It is critical that the teeth of the rake penetrate well into the surface and break up any smearing of clays that might be present on the surface of the soil. If you use a backhoe, attach fabricated raker teeth to each side of the bucket. Keep the backhoe bucket perpendicular to the trench bottom to minimize compaction. If the soil is sand or caliche, it will not be compacted, so there's no need to worry about these issues. To prevent further compaction, try not to walk on the finished trench bottom. If foot traffic is necessary, use planks to spread out the worker's weight. For both level and sloping sites, trenches should be connected by a header or manifold trench. The far ends of the trenches may be connected on the level sites to further improve wastewater application. If you have only 1 or 2 trenches, many regulations require no distribution box. However, if you have more than 2 trenches, a distribution box may be required. Check your local regulations. A site that restricts trench length to less than 75 feet will often require a distribution box. If a distribution box is required, make sure it rests on undisturbed soil and use a footing for stabilization. Be careful the distribution box doesn't tip during backfilling or settle after backfilling. If the distribution box is not level, it will not distribute the flow evenly. When constructing a chamber drain field, it is very important that the trench from the septic tank to the drain field be level. The trench for a gravel and pipe system can be constructed with or without a slope. However, the drain field pipe must be sloped. One of the difficult details in constructing the drain field is establishing the slope for the drain pipe. There are a number of ways to perform this task. Some are more accurate than others, but in general, the more accurate techniques require more equipment and expertise. The least accurate will probably be adequate if it is done carefully. Techniques were discussed earlier in the section on pipes entering and leaving the septic tank. Once the trench is done, it is time to place the distribution system. Until recently, the use of gravel and pipe for a drain field was very common. Use washed gravel ranging in size from 3/4 inch to 2 1/2 inches, or other trench fill material that has been approved by regulators. Carefully place the gravel over the bottom of the trench to a depth of 12 inches or regulation depth. The gravel must be completely free of fine material, clay, and silt, or this fine material may plug the soil at the bottom of the trench. Then level the gravel before you place the pipe. Lay down a 4-inch diameter perforated pipe on a maximum slope of 3 inches per 100 feet. Pipe for the distribution lines must meet local and state specifications. Do not use coiled perforated plastic tubing because the tubing will not maintain the slope or lay flat. These steps of placing the bottom gravel and placing and leveling the pipe can be combined into a single operation by placing the pipe on standoffs or chairs, which hold the pipe at the desired elevation. The gravel is then simply dumped in and smoothed off. During the assembly of the plastic piping in the trenches, it is important to ensure that the perforations are not at the bottom of the pipe. Ensure outlet holes are at 4 and 8 o'clock positions and do not point straight down. Place caps at the end of the pipes if they are not connected. Carefully cover the pipe network with additional washed gravel or approved aggregate to a depth of at least 2 inches above the top of the pipe. Next, place a backfill barrier such as a synthetic fabric filter or 4 to 6 inches of marsh hay or straw or untreated building paper over the gravel cover. Backfill to 6 inches above ground level. This completes your traditional gravel and pipe drain field. Chamber drain fields are quickly becoming more popular than gravel and pipe drain fields. The trench preparation for the installation of chamber systems is the same as traditional gravel and pipe drain fields. However, there must be no slope on the trench bottom. The chamber systems have a number of distinct advantages. There is no rock to handle. The materials for an entire drain field can be loaded on a single pickup truck. The assembly can be performed by one person, and there are no special tools required. But there are a number of cautions. Some manufacturers claim a chamber drain field can be sized smaller than a gravel and pipe drain field. Do not reduce the size or length of the drain field when using the chamber system. This may lead to early drain field failure. The drain field should be sized the same for a gravel and pipe system. Also, the chamber system is susceptible to certain types of damage. It is important to keep gophers, prairie dogs, and other burrowing animals away from the chamber system. If they burrow into the chamber, standing water such as irrigation or rain may flow through the opening from the ground level into the chamber, and the water may fill the chamber with soil, requiring replacement of the drain field. Chamber system assembly is very simple. Screw the splash plate onto the bottom of the end plate for the first chamber. Screw the end plate into the inlet end, which is the end without interlocks on it. This is the end that will be closest to the septic tank. Do this at your convenience, outside of the trench or in the trench. Place this assembled unit in the trench with the interlocks facing downstream. Place the pipe through the inlet opening and position it so the end of the pipe is over the splash plate. In a chamber drain field, the pipe brings the water into the system but does not extend into the system. Connect the remaining chambers together to form the desired length of the trench. Ensure the interlocks are fully engaged. You may also choose to screw the joints together. As you place each section of the chamber, check that the trench is level. Screw the closed end plate to the downstream end of the last chamber. If the system is to be either a loop system or a series system, use an open end plate instead of the closed end plate. It is critical with these chamber systems that the sides of the systems be filled prior to backfilling. This provides support for the arch so that the chamber does not collapse or cut into the underlying soil during backfilling. Fill the sidewall area to the top of the slots with native soil and walk the soil into place. Now the chamber system is ready for the trench to be backfilled. For both the chamber and gravel and pipe drain fields, the trenches should be backfilled with the excavated soil and then smoothed off. Individual trenches can be dug and completed in sequence for ease of construction. Settlement may take 6 to 12 months. To prevent erosion, sod or seed the construction site immediately using grasses adapted to the area. At last, you have completed your septic tank and drain field system. With proper care and maintenance, it will serve you for 20 or more years. Proper care includes pumping every 2 to 5 years. Enjoy your new system and care for it well.
The preceding was a production of New Mexico State University. The views and opinions in this program are those of the author and do not necessarily represent the views and opinions of the NMSU Board of Regents.